at trigonometric equations in radians today. So last lesson we looked at solving trig equations in degrees. We're doing the same process, but we want our calculator in radians mode. And we are also dealing with our angles in radians. So we will need to make sure we know how to do that. So we can solve trig equations involving radians. We recognise we should be using radians by our domain. So our domain will say 0 to 2 pi or something involving pi. So that means that we're using our radians. So in our first question, we have cos x equals 0.34. Now our x is by itself. There's no a value in front of our x. So what that means is we want two solutions for this question. So our question is that we have cos x equals 0.34. Our 0.34, is it positive or negative, the 0.34? Positive. So because it's positive, we are working in our ASTC. So we're in our positive quadrants for cos. So that is our A quadrant is always positive and our C quadrant. Now, with our ASTC, when we're talking about radians, we have that it goes around from 0 to pi, because pi is 180 degrees, to 2 pi is 360 degrees. If we're in our A quadrant, it is always just what theta equals. If we're in our C quadrant, when we're in degrees, it's 360 minus, so we will be doing 2 pi minus theta. Okay, what we're going to do is our calculator should be in radians. We are going to let cos theta equal our 0.34. Okay, if there was a negative, our negative would go away here because our sign of 0.34, positive or negative, just tells us which quadrant we're in. What we need to do is we'll have that theta equals inverse cos, so cos to the power of -1 of 0.34. So our calculator should be in radians. We should have a little r. And what we do is we go shift cos 0.34 and we're going to get our answer to be a decimal. So it's going to be 1.223879429. So for our answers for x, because we are in our A quadrant, it will be theta. And because we're in our C quadrant, it is 2 pi minus theta. So we will have that x is equal to 1.22 ... and that 2 pi minus our theta of 1.22 ... Now, we obviously know that 1.22 ... is just going to stay like that. We are going to answer this to two decimal places. So we're going to say that it's 1.22 for our first answer. Then to get our second answer in our second quadrant, we'll go 2 pi minus our answer to get 5.0593 ... Okay, we're going to round these to two decimal places. So we'll have our answer is equal to 1.22 and 5.01. Oh, not 5.01. What am I talking? 5.06. Sorry. Okay, does that make sense? Was everyone's calculator in radians be able to do that? Okay, our next one here, what we have is root 3 tan x equals -1. Now, when we're solving equations, we need our tan x to be the subject. And right now we have a root 3 in front of it. So what we need to do is we need to divide by our root 3. This means that we get our equation to be tan x equals -1 over root 3. Now I'm going to draw my ASTC symbol off to the side. Oh, that's not in the middle. Now, I have that tan x equals negative. So because it equals negative, that negative is telling me which quadrants tan is negative in. So tan is negative in our sine quadrant and our cos quadrant. So 0, 2 pi, and pi. So if we're in our sine quadrant, it is pi minus theta. If we're in our C quadrant, it is 2 pi minus theta. So we need to find theta. We are now going to let tan theta equal 1 on root 3. So that negative has gone away. All it tells us is which quadrant we're in. Now, to work this out on our calculator, we can go shift tan 1 on root 3. Oops, no we can't. Yes, we can. What has happened? I have an error. Yep, when we do that, our calculator will tell us that our answer is pi on 6 because we all have the new calculator. Okay, so we get that theta is pi on 6. We then have that x is equal to pi minus theta and 2 pi minus theta. So this is a case where we have to find the acute angle by itself. So then we are going to have that x equals pi minus our pi on 6. And we will have that 2 pi minus our pi on 6. Now our calculators can handle this. If you don't have the new calculator, you replace your pi symbol with a 1 here. So we'll go shift pi minus pi on 6 to get the first angle to be 5 pi on 6. And then the same with the second angle, 2 pi minus pi on 6 is 11 pi on 6. Okay. Once you've done that, are we on a new page? Yeah, go to the new page when you've done that. If you can't find theta by using your calculator, you can use your exact triangles on your reference sheet as well. All right, are we all good to move to the next example? Okay, the next example, we have sine squared x minus sine x equals 2. Now, we had questions with sine squared minus sine x vibe in yesterday's questions, which we didn't explicitly go over. So we're going over them now. Okay, what we want to do first is we want to minus that 2 to the other side. What we will have is sine squared x minus sine x minus 2 equals 0. Now, this is a quadratic equation. It's a bit confusing because there's the sign in there. Some people will be able to see it and factorize it straight away. Other people might get confused. So what we do here is we get rid of the sign by replacing it. So we're going to let sine x equal any other letter apart from x because x is in the question. So of course we pick m. This means we will have, instead of sine squared, we'll have m squared minus, instead of sine x, we'll have m minus our 2 equals 0. Now, what we want to do is we want to factorize this. So, our factors of minus 2 that add to give minus 1 are going to be negative 2 and positive 1. So, we'll have m minus 2 times m plus 1. So, therefore, we get that m equals positive 2 and negative 1. What we then do is we put our sign back in. So we say let m equal sine x. So what we'll get is we'll get that sine x equals 2 or sine x equals minus 1. So we get these two equations. Now, what we have to do here is whenever we have that sine x equals 1, sine or cos equals 1, 0 or 1, we want to refer to our sine curve, okay? And there's something funny going on with sine x equals 2. So what we're going to do is we are going to draw our sine curve off to the side. So we'll have pi on 2, pi, 3 pi on 2, and 2 pi. What is my y values for sine? What y values do I want on there? I just want, so sine, what's the maximum that sine y equals sine x when I graph that goes up to? It goes up to 1, and the lowest value it goes to is -1 when we graph sine. Now, when I graph my y equals sine x curve, oh, that's good. Oh, can sine x equal 2 then? That's the question that we're investigating. What happens if you go shift sine of 2 in your calculator? An error, right? So why we get that error and why, so this is going to have no solution, right? Because if we were to graph sine, does sine start at 1 or 0? I can't remember. It starts at 0, good. So it goes 0, does it go up or down? Very good. Well, that's why I'm testing you. All right, that's our sine curve, y equals sine x. So what we have to do is, that's why these curves were so important to know how to draw. Okay, so if we were to extend our y-axis up and we have 2, does our sine curve exist at 2? No. So that's why there's no solution. All right, and this is because as our range of our sine curve is -1 to 1. So our y value of 2 is outside our range. Does that make sense to everyone? Yeah. So we can only deal with when sine equals -1, 1 or 0. Okay. Can we find, so we can't find a solution for sine x equals 2. Can we find a solution for sine x equals -1? Yeah, we can. So if we were to draw a line at y equals -1, what x value does it substitute through? Yeah, 3 pi on 2. Okay, so therefore our answer is x equals 3 pi on 2. And that's our only solution for this. How cool.
How do we know if there's only one solution?
We don't. We have to test it and check using our graph. Yeah. It's a bit tricky, those ones. Okay, we have one more example, I believe, or there might be another one. I can't quite remember. Okay, so what we have in our next example is tan x minus pi on 4 equals root 3. Now, we have that it's tan x equals already, which is great. So what we have to do, though, is we have to change our domain because something is affecting that x. So we have to look at our domain. So our original domain for this question, going all the way back to the start of the question, our original domain was 0 to 2 pi. Amazing. So our original domain is 0 is less than or equal to x is less than or equal to 2 pi. Now, what we want is we want this x here, we want that to be x minus pi on 4. Okay, so what do we do to both sides? What do we do to x to get x minus pi on 4? We minus pi on 4. So we have to minus pi on 4 to our inequality to each term. So what's 0 minus pi on 4? Yeah, minus pi on 4. And then what's 2 pi minus pi on 4? 7 pi on 4. All right, your calculator could tell you that. So that's what our new domain is. Okay, so yesterday we looked at when we had like a 2 in front of our x and we had to change our domain. So if anything is affecting that x specifically, okay, we have to change our domain. Now, we'll jump back to that in a second. What we have is we are going to let tan theta equal root 3. So if tan theta equals root 3, what does theta equal? Pi on 3, right? When we go shift tan root 3, we should get pi on 3. Okay, so we need to draw two different ASTC symbols for this one. So ASTC, ASTC. Draw two for me. Okay. The top ASTC is going to be our positive one. So it's going to be 0, pi to 2 pi. This one is going to be 0 to negative pi. I'm even going to put a negative pi on 2 down here just to help us out. So the top one is our positive ASTC. The bottom one is our negative ASTC. Now, our new domain says that we go from negative pi on 4. So that's down on our bottom one. All the way around to our positive version of 7 pi on 4. Okay? That is where we're working with. Now, this one's a nice question because this new domain is actually not going to affect us because we're dealing with tan. Now, with our tan, is our tan root 3, was it positive root 3? So because it was a positive root 3, sorry, we should have probably written it out again. What we have is tan is positive in our A and our T quadrant. So within that domain that we have demonstrated on our two ASTCs, we only really need to be working between our 0 and 7 pi on 4. But if this question was cos, it would be working in our C, A, and this C as well. We will only still have two solutions, but it will depend on what the acute angle is, on whether it's in the negative or if it's in the positive. Okay? Our answers at the end are going to end up between 0 and 2 pi. So, what we have here is our answers for x. If we're in our A quadrant, it's just theta. If we're in our T quadrant, it is pi plus theta. So what we will have is that x is equal to theta and it is equal to pi plus theta. So we have that x is equal to our pi on 3 and pi plus our pi on 3. Now, we don't have to do anything to our pi on 3, so x will just equal our pi on 3. But we need to work out what pi plus pi on 3 is. Our calculator will handle that. So it will be 4 pi over 3. And that's it.